Have you ever gazed up at the night sky, those twinkling stars scattered across the vast canvas of space, and wondered about our place in it all? Have you pondered the nature of reality itself? What if I told you that some of the most brilliant minds in physics are exploring the possibility that everything we know, everything we experience, could be part of an incredibly advanced computer simulation? It sounds like something straight out of the Matrix, right? But stay with me. The universe is a strange and wondrous place, full of mind-bending mysteries that challenge our very understanding of how things work. From the smallest particles to the largest cosmic structures, physics constantly throws curveballs, forcing us to expand our perspectives and embrace the unknown. Get ready to dive deep into some of the most fascinating and bizarre theories that might just make you question everything you thought you knew about reality. We're about to embark on a thrilling journey through the cosmos, exploring concepts that blur the lines between science fiction and bleeding-edge science. Fasten your seatbelts, folks, because things are about to get weird. Let's start with a real head-scratcher simulation theory. This theory proposes that what we perceive as reality is actually a sophisticated computer simulation, perhaps created by a civilization far more advanced than our own. Think about it. Our video games get more realistic every year. Who's to say that we haven't already reached a point where simulations are indistinguishable from reality itself? Now I know what you're thinking. Neil, that sounds like pure science fiction, and you're right, it does. But here's the thing, some very smart people take this idea seriously. The philosopher Nick Bostrom, for example, argues that if it's even possible to create such simulations, then it's highly probable that we're in one right now. Why? Because if simulations are possible, then a highly advanced civilization could create countless of them. The odds of us being in the original real reality would be astronomically small. Think of it like this. If a civilization could create billions of simulated universes, wouldn't it be more likely that we're experiencing one of those simulations rather than the one true reality? It's a mind-blowing concept, but it's grounded in logic and probability, and there's more. Some physicists have even suggested that we might be able to find clues within our own universe that point to its simulated nature. Imagine searching for glitches in the Matrix. They believe that by studying the behavior of particles at the quantum level, we might uncover subtle anomalies, tiny deviations from the laws of physics that could betray the existence of the underlying code running our simulated universe. Of course, simulation theory remains highly speculative. We don't have concrete evidence to prove or disprove it. But it's a fascinating thought experiment that forces us to question the very fabric of our existence. Hold on tight, because things are about to get even weirder. Let's talk about the multiverse, the idea that our universe isn't the only one but rather just one of an infinite number of universes existing simultaneously. Imagine an endless sea of bubbles, each bubble representing a different universe with its own unique laws of physics, its own history, maybe even its own versions of you and me. This might sound like pure science fiction, something out of Doctor Strange or Rick and Morty, but the multiverse isn't just a product of wild imagination, it actually arises from some of the most well-respected theories in modern physics like string theory and inflationary cosmology. String theory, for example, suggests that the universe is made up of tiny, vibrating strings, and the way these strings vibrate determines the properties of particles and forces. But here's the catch: string theory requires the existence of extra spatial dimensions, dimensions beyond the three we experience in our everyday lives. These extra dimensions could potentially accommodate countless other universes, each with its own unique configuration of strings and therefore its own set of physical laws. Then there's inflationary cosmology, which proposes that our universe underwent a period of exponential expansion in the first fraction of a second after the Big Bang. Inflation elegantly explains some of the universe's observed properties, but it also predicts that our universe is just one of many bubble universes that popped into existence from a primordial quantum foam. The multiverse is a mind-boggling concept, no doubt about it, but it's a tantalizing possibility that could explain some of the deepest mysteries of our universe and open up entirely new realms of exploration. Chapter 3. Spooky action at a distance, unveiling quantum entanglement. Prepare to enter the realm of quantum mechanics, where things get really strange, even for physicists. Let's talk about one of the most bizarre and counterintuitive phenomena ever observed: quantum entanglement. This is the idea that two particles can be linked in such a way that they share the same fate, no matter how far apart they are. Imagine you have two coins flipped at the same time. If one lands on heads, you know instantly that the other must land on tails, right? That's because the two coins are correlated. But here's where quantum entanglement gets really weird. In the quantum world, particles are like fuzzy dice, existing in a superposition of states, meaning they're both heads and tails at the same time until you actually measure them. Now imagine two entangled particles, each in a superposition of states. When you measure the state of one particle, you instantly force the other particle to collapse into its corresponding state, even if those particles are light years apart. It's as if the two particles are communicating faster than the speed of light, which Einstein told us is impossible. This spooky action at a distance, as Einstein famously called it, has been experimentally verified time and time again. It's one of the most well-established phenomena in quantum mechanics, even though it seems to defy common sense. Entanglement is not just a theoretical curiosity. It has profound implications for our understanding of reality and the potential for developing revolutionary technologies. For example, scientists are exploring how to harness entanglement for quantum computing, which could lead to exponentially faster computers capable of solving problems that are currently intractable for even the most powerful classical computers. Entanglement could also revolutionize communication, allowing for perfectly secure transmission of information. Quantum entanglement is a prime example of how the universe often operates in ways that challenge our intuition and force us to expand our understanding of what's possible. Chapter 4. Back to the Future. The Perplexities of Time Travel. Fasten your seatbelts because we're about to venture into the realm of time travel, a topic that has captivated the human imagination for centuries. Is it possible to journey through time, to witness historical events firsthand, or even alter the course of history itself? While time travel often seems relegated to the realm of science fiction, from H.G. Wells's The Time Machine to the Back to the Future movies, it's a topic that physicists have grappled with for decades. Einstein's theory of general relativity, which describes gravity as the curvature of space-time, suggests that time travel might indeed be possible, at least in theory. According to general relativity, massive objects warp the fabric of space-time, and this warping can affect the flow of time. One possibility for time travel involves wormholes, theoretical tunnels that connect different points in space-time. Imagine folding a piece of paper in half so that two distant points touch. A wormhole would be like a shortcut through the fold, allowing you to travel vast distances in space or even jump to a different point in time. However, time travel comes with its own set of paradoxes and conundrums. The most famous is the grandfather paradox. What would happen if you went back in time and accidentally killed your own grandfather before your parent was even born? Would you cease to exist? And if you ceased to exist, how could you have traveled back in time to kill your grandfather in the first place? These paradoxes highlight the mind-bending nature of time travel and the challenges of reconciling it with our current understanding of physics. While we haven't cracked the code of time travel just yet, it remains a tantalizing possibility, a testament to the boundless possibilities of the universe. Chapter 5. Our Holographic Universe. Is reality just an illusion? Get ready for another mind-blowing concept, the holographic principle. This theory suggests that our three-dimensional universe, with all its depth and complexity, might actually be a hologram, a projection of information encoded on a distant two-dimensional surface. Think of it like a credit card hologram, which appears three-dimensional but is actually just light reflecting off a two-dimensional surface. The holographic principle arises from the study of black holes, those cosmic monsters with gravitational pulls so strong that nothing, not even light, can escape their clutches. Physicists studying black holes discovered something remarkable. The information about everything that falls into a black hole doesn't disappear but seems to be encoded on the black hole's event horizon, the point of no return. This realization led to the profound idea that perhaps our entire universe is a holographic projection, with information about everything in it, including us, encoded on a distant two-dimensional surface at the edge of the observable universe. The holographic principle is still highly speculative, but it has profound implications for our understanding of reality. If our universe is just a hologram, then what does that say about our perception of reality? Is everything we experience just an elaborate illusion? And if so, who or what is projecting this illusion? These are questions that physicists are still grappling with, questions that blur the lines between science, philosophy, and even spirituality. The holographic principle is a testament to the power of human imagination and our relentless pursuit of knowledge, even when it leads us to question the very nature of reality itself. So, there you have it, 5 mind-bending physics theories that challenge our perceptions of reality and push the boundaries of human understanding. Are we living in a simulation? Is our universe just one of many? Can we travel through time? Is reality itself an illusion? These are questions that have no easy answers, but they're questions worth asking. They remind us that the universe is a vast and mysterious place, full of wonder and endless possibilities. Keep exploring, keep questioning, and keep your mind open to the extraordinary. What are your thoughts on these mind-bending theories? Share your comments below, and don't forget to subscribe for more explorations into the mysteries of the cosmos.